Namaste. In the last class we were in the chapter Mensuration and we have come across in finding the CSA and TSA of cylinder. So today we are going to learn the new concept called volume. When you walk into McDonald's and order Coca-Cola, you get to choose between three variants: regular, medium and large. What is it? That's difference between these three choice. Well, one look at the glasses and are used to serve them tells you that the only thing different is the amount of Coca-Cola contained with it. So here we find the three different measure of glasses. One is very big, the other one is medium and the other one is small. Does all the three glasses contains the same volume? So let me try by filling some grains into the small glass. Now here we can see some grains are filled in the glass. Let me pour these grains into this glass and see whether it occupies the same measurement or not. Yes, not at all. You can see there is a little bit of space which is not filled up to the brim of the glass. So the same grains I'll pour it into the another glass and see whether it fills into this glass. Yes, is the glass is filled with completely with the grains? No. So it indicates that the capacity of this is smaller than this and the capacity of this is smaller than this. So the capacity is nothing but the volume. So generally I can say volume of a solid is the measure of space occupied by it. Now let me pour some of the grains into this again. Is it filled? No. Means it is completely half filled of the glass. Right? So let me pour this into this glass. Is it completely fills or any grains left out? Yes, the grains are left out, which indicates that the capacity of this glass is lesser than this glass. So it totally depends upon the volume of a solid. So volume of a solid is the measure of space occupied by it. So volume of a solid is the measure of space occupied by it. Now let us know units of volume. So given that volume has three dimensions, it has a cubic measure of length. Unit of side, unit of volume, then centimeter, unity becomes centimeter cube, millimeter, millimeter cube, meter, meter cube. Conversions: 1000 centimeter cube equal to 1 liter and 1000 liter makes 1 meter cube. Now let us find the formula in finding the volume of cube and also cuboid. So generally we say volume of a solid is nothing but base area into height. So to find the volume of cuboid now, so we know that generally the cuboid is made up of rectangles in all the faces. Therefore, the base area will be in the form of rectangle and height. Therefore, volume of cuboid is base area into height. Base area rectangle, therefore L into B, and the height is H. Therefore, volume of cuboid is L into B into H. Then comes volume of cube. As we know that the cube is made up of same face of square, that is same length of squares which are having 6 faces. Therefore, the volume of cube is base area into height. So here the base area is made up of square. So I can tell side into side and height measures also same. Therefore, the volume of cube is side cube, or we can tell a cube. So all the measure of edges in the cube are same in length. Therefore, L into B into H can be written as A into A into A. Then volume of cube becomes A cube. If you are writing S into S into S here, then volume of cube becomes S cube. So the unit for volume is cubic units. If it is centimeter, all the dimensions are centimeter, then it becomes centimeter cube. If all the dimensions are millimeter, then it becomes millimeter cube. If all the dimensions are in meter, then it becomes meter cube. Now we'll solve the questions based on this formula. Worksheet 5, first question. Two cubes, each of side 6 cm, are joined together. Name the new solid formed and also find its volume. So here he is asking us to join the two cubes. So let me draw the cubes here. So two cubes are joined together. So here we can find the two cubes which are joined together. We obtained a new figure called cuboid, and the side of each cube is 6 cm and 6 cm, and breadth is 6, height is 6, because we know that the edges of the cubes are same. Therefore, the cubes are joined side by side. Therefore, the length becomes 6 plus 6 equal to 12 cm. Breadth remains 6 only and height remains 6 only. Then here I have three different dimensions. Therefore, the figure obtained, the solid obtained is a cuboid. So after writing the new solid formed, here is asking find its volume. So we'll write volume of cuboid equal to L into B into H. We have come across here the volume of cuboid is nothing but base area into height. Base area will be L into B and the height is H. Therefore, the volume of cuboid is L into B into H. Check all the dimensions are same. Yes, then you can substitute 12 into 6 into 6. 12 into, we know that 6 6 are 36. Then multiply these two. Then 36 into 12 is 432, and the unit becomes centimeter cube. Therefore, the volume of solid is 432 centimeter cube. Write the conclusion, children. So keep remember, always the volume of solid will be in cubic units. Now let us move to second question. Find the height of a cuboid whose volume is 275 centimeter cube and base area is 25 centimeter square. So first let us write the given things, that is volume of cuboid. Volume of cuboid equal to 275 centimeter cube and base area equal to 25 centimeter square. We know that volume of cuboid is L into B into H, or the other way of writing the volume of any prism is base area into height. So volume of cuboid equal to base area into height. Then base area is 25 into H, because we do not know the height, and the volume is given 275, and here both the units are same, that is centimeter, but here it is cubic centimeter and here is square centimeter. Then H equal to 275 divided by 25, because the 25 and H are under multiplication. So the multiplication of 25 will change it to division. Then 275 divided by 25 is nothing but 11. So H equal to 11 and the unit is centimeter. Thus, conclusion you can write, thus height of cuboid is 11 centimeter, because 25 ones are 25, 25 ones are 25, 2 remains, 25 ones are 25. Thus the height of cuboid is 11 centimeter. Let us move to third question. The dimensions of a box are 60 centimeter, 54 centimeter and 30 centimeter. So here the dimensions are 3 different, therefore the box is in the form of cuboid. How many small cubes of side 6 centimeter can be placed in the box? Means he is going to place the small cubes inside the box, that is inside the cuboid. Therefore this is the concept of volume, not the surface area. He is placing the small box in the cuboid. Means filling of something in the box is nothing but volume concept. So here we can see the cuboid is drawn, okay, whose dimensions are 60 centimeter, 54 centimeter and the height is 30 centimeter. Inside the cuboid the small cubes are placed whose dimension is 6 centimeter. Such that how many cubes can be placed inside the cuboid? It's nothing but total volume divided by volume of each cube. So cuboid length is equal to 60 centimeter, breadth equal to 54 centimeter and height is 30 centimeter. If the dimensions are given like this, it indicates length, breadth and height. And the cube dimension is given, that is only the side, which is 6 centimeter. Then number of cubes equal to number of cubes that can be placed is nothing but volume of cuboid divided by volume of cube. Then volume of cuboid is L into B into H divided by volume of cube is side cube. Then substitute the values. L value is 60, B value is 54 and the H value is 30 and check all the units are same. Then only you can, even the side of cube must also should be the same unit what the cuboid consists of. Therefore here it is same, so you can write 6 into 6 into 6. 6 ones are 6 5s are 30, 6 ones are 6 10s are 60, 6 ones are 6 9s are 54. Then we'll get 10 into 9 into 5. Then 9 5s are 45, 45 10s are 450. Thus 450 cubes can be placed in the box. Now let us move to fourth question. If each edge of a cube is doubled, then how many times will its surface area increases and how many times will its volume increases? So here before increasing, let us consider, let the edge of the cube be, let the edge of cube be A units. Then first find its surface area and find its volume also. Then surface area equal to 6a square, that is TSA of cube 6a square, and here the edge is taken a, therefore it remains as a 6a square units, that is unit square. Then volume of cube becomes, we know that volume of a cube is a cube. Since the edge is also taken a, therefore it remains as a cube only. If the edge is doubled, according to the question, if the edge is doubled, then 2 into a, doubling is nothing but multiplication with the 2. So 2 into a becomes 2a units. The measure of edge is 2a now. And is asking us to find the surface area, how much times it increases. We know that surface area is nothing but 6a square, and in place of a now we need to take it as 2a, that is 2a whole square. 6 into 4a square, then 6a square into 4, then 4 into 6a square. Initially we have surface area was 6a square, so this 6a square is remains as it is here, which indicates that its surface area increases 4 times. The same way the second sub question is asking how many times will its volume increases. Then volume of cube is nothing but a cube, and which equal to the edge of a square cube is 2a, therefore 2a whole cube, it becomes 8a cube, that is 2 cube is nothing but 8 and a cube remains as it is. And initially we had a volume as a cube, but here we have 8a cube, which indicates that 8 times increases in its volume. This is how we need to solve. Let me move to fifth question. A matchbox measures 4 cm into 2.5 cm into 1.5 cm. What will be the volume of a packet containing 12 such boxes? So if I know the volume of one box, then I can find what is the volume of 12 boxes, right? Then volume of box equal to volume of matchbox. Volume of matchbox is equal to L into B into H, because here the dimensions are length, breadth and height whose measures are different, therefore it will be in the form of cuboid. So 4 into 2.5 into 1.5, we know that 25 4s is 100, and here after point we have one number, therefore 10.0 into 1.5, we know that 15 tens is 150, clear, and after point we have only one number, therefore 15 centimeter cube. But here he is asking volume of 12 such kind of packets. So volume of 12 matchbox. So in one packet it consists of 12 boxes. Therefore volume of 12 boxes equal to 12 into 15. Here 15.0 is nothing but 15 only, children. Then 15 into 12 is 180 centimeter cube. Therefore volume of 12 matchbox equal to 180 centimeter cube, or we can tell volume of packet is nothing but 180 centimeter cube. Inside the packet we have 12 such kind of boxes. So now we'll go to sixth question solving. So volume of a cube is 1000 centimeter cube. Find its total surface area. He is asking us to find the total surface area. We know the total surface area is equal to 6a square, means where the edge of a square cube is a. But here given is volume. So from the volume you find the measure of edge and then find its total surface area. So volume of a cube equal to 1000. Then volume of a cube formula is a cube equal to 1000, and we know that 1000 is a perfect cube of 10. Then a equal to 10 centimeter, which implies edge measures is nothing but 10 centimeter. Now you find the TSA. TSA of cube equal to 6a square, then 6 into 10 square. We know that 10 square is nothing but 100, then equal to 600. Since we are finding the area, therefore it will be the unit as centimeter square. This is how solving of sixth question. Now we will move to seventh question. How many planks, each of which is 2 meter long, 2.5 centimeter broad and 4 centimeter thick, can be cut off from a wooden block 6 meter long, 15 centimeter broad and 40 centimeter thick? So here the planks have been cut from the wooden block, means the volume of wooden block is greater than the volume of each plank. So first let us write all the dimensions of plank and also the wooden block. So here the length is in meter, so therefore let me convert into centimeter. 2 into 100 equal to 200 centimeter, and rest other two dimensions are in centimeter. Then go for wooden block. Here also the wooden block is having in meter, so I'll convert into centimeter, will get 600 centimeter. Now he wants the number of planks. So the number of planks equal to volume of wooden block. So here the dimensions of wooden block are different, therefore it will be in the form of cuboid. Even the volume of each plank. So here the dimensions of a plank are also different, So plank will also be in the form of cuboid. So length into breadth into height divided by L into B into H. Now first in the numerator you write down the dimensions of wooden block, that is 600 into 15 into 40 divided by volume of plank is 200 centimeter into 2.5 into 4 centimeter. Now cancellation, 00 get cancels, 2 ones are 2 3s are 6, then 4 ones are 4 10s are 40. Let me write 3 into 15 into 10 divided by 25, and here I'll remove the point by placing the number of zeros in the numerator. After point we have one digit, therefore 1 0 in the numerator. Now 5 3s are 15, 5 5s are 25, 5 1s are 5 2s are. Now multiply 3 3s are 9, 9 2s are 18, and this 0 as it is, that is 180 planks. Therefore number of planks equal to 180. This is how we need to solve, children. Now let us move to next question, that is question number 8. 3 solid metal cubes with edges, 6 centimeter, 8 centimeter and 10 centimeter respectively are melted in the sense concept of volume, together and formed into a single cube. Find the volume of the new cube. So here the volume of cube 1 plus the volume of cube 2 plus the volume of cube 3 is nothing but the volume of big cube. So we know that volume of a cube is equal to a cube. So here sum of all these cubes, that is 6 cube plus 8 cube plus 10 cube is equal to a cube. That is, we get a big volume. Then what is 6 cube? 6 cube is nothing but 216 plus 8 cube is 8 8 64, 64 8 is 512 plus 10 cube is 1000 is equal to a cube. Then you sum up all this, that is 512 plus 1000 plus 216. Then we get 1216, which is nothing but a cube. So here he is asking the volume of new cube so far obtained. So the volume of new cube is 1216. Write down the conclusion. Thus the volume of new cube is 1216, and write its unit, that is centimeter cube, because he is asking volume. This is how we need to solve, children. Now let me move to 9th question. Find the volume of a cube whose surface area is 150 meter square. So here surface area is given. From the surface area of cube, first find the edge of cube. After finding the edge of cube, then you find the volume of a cube. So solution, given information is surface area. Surface area of cube is equal to 6a square, because we know that cube consists of 6 faces. Then 6a square equal to 150. Now you find the length of a now. Then a square equal to 150 divided by 6. 6 1s are 6, 6 2s are 12, 3 remains, 6 5s are 30. Then a square equal to 25. We know that 25 is a perfect square of 5. Then a equal to 5 centimeter. But what is a? A is nothing but edge of a cube. Edge of a cube equal to 5 centimeter. But is asking us to find the volume. Then volume of cube equal to a cube, which is nothing but 5 cube. Then 5 cube is 125, and the unit is centimeter. Therefore for volume it becomes cubic centimeter. This is how solving the 9th question. Now let us move to 10th question. Find the volume of a cube, one face of which has an area of 81 meter square. Here also he is asking us to find the volume only, but the given information is one face area is 81 meter square. So we know that the cube is made up of the two-dimensional figure called as square. So whose one face area, that is area of square, is 81 meter square. So 81 meter square is nothing but area of one face. So here the faces are made up of squares. Therefore area of square is 81 meter square. So area of face, that is square, equal to 81 meter square. We know that area of square is a square, that is s square. 81. We know that 81 is a perfect square of 9. Then a is 9 meters. But what is a according to our assumption? A is nothing but edge of a cube, the length of edge of a cube. From this we need to find the volume. Then volume of a cube equal to a cube, then 9 cube, then which equal to 729 meter cube, because we are finding its volume. Example 12. A garden is in a form of a cuboid of dimensions 60 meter, 40 meter, 30 meter. How many cuboidal boxes can be stored in it if the volume of one box is 0.8 meter cube? It's of same kind of question what we have solved in worksheet 5, that is question number 7. Number of boxes equal to volume of garden by volume of one box, substituting all the values. After simplification we get 90,000 boxes. Thus 90,000 boxes can be stored in the godown. Moving to example number 13, find the side of a die whose volume is 64 centimeter cube. So here volume of die is given. So volume of die generally will have in the form of cube. So volume of cube equal to a cube. Then 64 equal to a cube. We know that 64 is a perfect cube of 4. Then 4 cube equal to a cube. Then the value of a equal to 4, which is in centimeter. Then what is a? A is nothing but edge of a die. Then what he is asking us to find? He is asking us to find the side of a die. So we got side of a die equal to, side of a die is 4 centimeter. That's all, children. This question they'll ask only for 1 mark. So in worksheet 5, whatever the 10 questions are solved, children, all questions are very important for the examination point of view. So please practice well. So this completes our today's class. We'll meet again in the next class, children. Thank you. Have a nice day. Thank you, children.